So now I'm recorded. So I was just in the middle of explaining there are two interesting parts of probability theory. The first part is that you can actually start with the meaning and then by saying, okay, I want to come up with a calculus for processing information, and start with, well, what kind of conditions or constraints should that calculus adhere to? And that is explained in the note by Ariel Katica, but he actually got it from other people before him, particularly this guy, Richard Cox. And so if you take that route, then you can actually derive that probability theory, meaning product rule and sum rules, are the rules for processing information. So here you started with the meaning and you derived product and sum rules. They are not just some arbitrary rules, they're actually the rules that you should use if you want to compute, if you want to update your state of information as new information becomes available, for instance, in the form of data. And that's what we usually do with machine learning. The second interesting thing is that, well, about this meaning of probabilities is that it's a state of knowledge, right? So it's not really a state of nature. It's really a state of your knowledge about something in nature. And the example that I like to give, and it's also in the exercises, is, well, for instance, a speech signal. Is a speech signal a random signal or a deterministic signal? It's actually not a question, right? A speech signal is just what it is. If I would have an ideal microphone and I could make a noiseless recording of my speech, then out of that microphone would come just a sequence of numbers, and that's the speech signal, and I would be 100% certain that's it. So it's totally deterministic. However, if I have a noisy microphone, or before I record my speech signal, I have a lot of uncertainty about what that speech signal actually is. So in that case, I have to describe it by probability distribution, and then people would say, oh, then it's a random variable, it's not a deterministic variable. And that's, to me, so I don't really think it's, there's much difference between a random variable and a non-random variable. Variables are containers for values, and your state of knowledge determines whether you describe that the variable by a probability distribution or just by a value. So those are the two important things, and then it's just a matter of getting acquainted with, well, working with probability theory. So working with the sum and product rule, and some variations of these rules, like marginalization and Bayes rule. And that's all that's going on in this class, and there are some exercises. Some of these exercises are rather difficult, probably more difficult than we would ask in class, particularly if there is a long derivation that would probably not happen in a test. The other comment I want to make is about this. There is, in the material section, I asked you to read a section from Ariel Katicha's monograph, right, pages 7 through 26. By reading, I really mean just reading. I don't mean studying in the sense that I will not ask you in the exam to reproduce the proof of or his arguments, right? It's just that I want you to read through it so that you can convince yourself a bit of the arguments that Ariel Katicha uses to derive probability. And once you get a feeling for that, then that's enough for me. I want you to be familiar with it. So by reading, it's just reading. And don't worry too much if you cannot follow the full argument of what he does there. That's really all the comments I wanted to start with. It's up to you now. If you have any questions about the material, please, or just about the class so far, please either speak up, or put it in the chat, and then we'll deal with it. Could you explain the example of the white black balls and the 2/3 probability? Okay, so let me see if I can share. I think the idea is the following. So you have a bag, and I think there was a white ball in that bag. And then you, no, sorry, you have a bag, and there is either a black or a white ball in the bag, but you don't know. So if I ask you, what is the probability that there was a white ball in the bag? And well, if I don't give you any other information, you would say about 50%. Okay. Then I do an experiment. I take a white ball and I put that in the bag, right? I can't see what's inside. I just shake the bag and I pick out blindly a ball, and it turns out to be white. And then I ask you again, so what is the probability that the remaining ball in the bag is a white ball? Now, for sure, if there was a black ball initially, it's still a black ball. And if there was a white ball, it's still a white ball, because I had a white ball, put in a white ball, and I pulled out a white ball. So the color of the ball in the bag is the same. Still, your state of knowledge has changed, because I could have picked a black ball, right? But I didn't. Let's say that I would have done this 1,000,000 times. Let's say that I have this bag with either a white or a black ball, and I don't know which color it is. But I take a white ball, I put it in, I shake, I pull out the ball, and I see it's white. I do the same thing. I put in a white ball, I shake, pull anymore that there used to be a black ball, right? It's now I would like you to actually translate this to a computation, and the answer is in I mean, there's a solution in the there's exercises with solutions. So I think I challenge you to actually go through the solution and try to understand it. But the intuition is that if I would do this many times, then and I always pull a white ball, the probability that the ball in the bag is black will go down and down, right? Or the probability that it's a white ball will go up. If I do it one time, the probability goes to 2/3. If I do it 1,000,000 times, the probability that it's a white ball is almost 1. So that's sort of the intuition behind that. So would you mean that if you had, I'm just reading the chat here, that if you had the first time drawn a black ball, the probability always stay 50-50? No. Okay, so this is an interesting thing to think about, right? So if there's a white or a black ball, I put in a white ball, I pull a black ball. Yes. Okay, so now we know that the two balls are black and white. Yes, I think that's true. By then you have enough information to solve this problem. True. Yes. I'm just waiting for anything else. So the chance of the unknown ball being white is 0. Yes. When you sure, if let's say if you have a ball, if you have a bag and there's either a white or a black ball in there, I throw in a white ball, I shake and I pick out a black ball, right? Then I know, I mean, everything has been revealed, right? So then I picked apparently the ball that was initially in there, and the chance that that ball is white is 0 by that time. Yeah. So what you see by this game is that the probability of whether something is a black or a white ball is not a property of the bag. It's not a property of the balls or the bag. It's a property of how much information do you have, right? That's the so that's the interesting thing about this example. To get you familiar with the idea that probabilities do not describe nature. They describe your knowledge about something, about nature in this case. Okay, great. Are there any other questions? I have seen that we have started to pose and answer questions on Piazza. I'm really happy with that, so please continue to do that. So and I think I also told that in the beginning, my plan is when I see a question to just wait a bit and see if the student group will collaborate on an answer. I would prefer to see that, and then maybe a day later, when I see an answer, I will endorse that, or one of the TAs will endorse it, and or if you think, well, there's a little bit more to say about it, then we'll add our own answer. But generally, we'll wait for you to provide the answers. And I think I would love to see a bit of collaboration in this class. Okay, so I see Matthijs has a question. You're also free to, you can type, that's totally fine, or you can just speak up. Note that if you type it, I will try to remember to repeat the question, because otherwise it will not show up in the, otherwise the question will not show up in the recording, right? Why are we using Big Blue Button instead of MS Teams? Well, Big Blue Button, the recording also shows the chat. Okay, super. There, I think both have, are not, both Big Blue Button and MS Teams aren't very good. For me personally, since I also work at a company that requires me to be logged in MS Teams, I can't have a dual login in MS Teams, so that always messes up my my setup. I'm working on a Mac, which is not a natural environment for MS Teams, and then having a dual or a requirement to be logged in on the TU side and on the GN side, it's just not working for me. This is one of the platforms that the let's say the EE department recommends, and also recently, I think the last week, they're also making also recommending MS Teams or making MS Teams available. I don't mind at some point trying to switch, but I if we can make this work, I'd like to stick to it. Are there any advantages to MS Teams that we cannot do here with Big Blue Button? I'm just waiting for the chat. It's more intuitive, more easier to connect with the voice. Okay. I think if you're all here, then it's intuitive enough in the sense that you logged in. But I have no problem trying MS Teams one of these weeks, so I'll look into that. I think what we will do is we'll try to do a poll on Piazza and ask you what is your preference. How about that? I will set up a poll at Piazza and ask people if they want to try MS Teams. Okay, so feel free to unmute your microphone or say something else in the chat. When I want to enable my mic, the audio is gone. I think a lot of people, the large majority, logged in, including you, without audio. As far as I know, when you log in to Big Blue Button, it asks you first, do you want to enable your microphone? I see that, Matthijs, that you were logged in just with a headphone. And so I don't think that. Yeah, I don't know if you can hear Bert when you choose microphone. That's
No, so Matthijs said that he logged in with headphones because otherwise he cannot hear you. But maybe that was just the small audio glitch at the beginning of the lecture.
okay. Okay, so yeah, so I think there are other people who have logged in with audio and they can hear me. So it's I don't think it's a inherent system limitation. Something went wrong probably with logging in. So are there any other questions about the probability theory class or the class before that, the introduction to machine learning? Really, the only thing I wanted to talk about there is this classification or this taxonomy of there are different types of machine learning. That's really, but that's not a very difficult class. The probability theory class is, I think, is a difficult class in the sense that it probably involves a switch of your interpretation of probability theory. The computations are the same as you've always done, but now you have to think of it as a state of knowledge, and that may grow on you, I hope. It's for some people that is actually a switch they cannot make. But if you do, then I think it will pay off a lot when you in the it's actually it used to be a bit of a contentious point in the statistics, the field of statistics, whether it was a good idea to interpret probabilities as states of knowledge or as relative entropies. I had one cell in the lecture notes talking about these two viewpoints, the frequentist and the Bayesian viewpoint. But since you can actually, if you start with a meaning as a state of knowledge, and then you can actually derive that the calculus that, let's say, that processes that updates your state of knowledge, that calculus is probability theory, that I don't think at the moment it's such a contentious viewpoint anymore. Okay, so the next class, and we will meet then on Wednesday. The next class is about applying probability theory to Bayesian machine learning. It's again just a sort of a framework class. There aren't really big practical applications yet. But what I hope that you'll get out of the next class is to see how, just with simple probability theory, you can really build up a whole framework for machine learning and for applying machine learning to prediction or to other applications. And you don't have to leave probability theory. Everything is just, in the end, comes down to applying sum and product rules. And that approach to machine learning is called Bayesian machine learning. So in a sense, the probabilistic approach to machine learning is the same as the Bayesian approach. So it's just of course, there are other approaches. There are non-probabilistic approaches, but I think that this is the, in a sense, the more fundamental approach, and the non-probabilistic approaches often can be seen as special cases in the probabilistic approach. So I hope you have time again to go through the lecture notes and the video guide and maybe make some exercises. And then on Wednesday, and also talk in Piazza about stuff that's not clear. And any remaining stuff we will discuss then next Wednesday. Unless anybody has another question, and please just feel free. I have the whole morning. Just put it in the chat. But unless there is no more question, I think we can adjourn. We can finish this meeting and move on to the next class. Any objections to that? No? Okay, great. Then sounds good. Good, sounds good to me. Then I'll look forward to seeing you next Wednesday. Oh, Bart still has one question. So go ahead, Bart.
And it's regarding the exercises. It's all possible to see on Jupyter, but it's also possible to have it as a PDF so I can print it. So because it works way better for me if I have it on paper than I have it on my computer screen.
Okay, so I think we can work on that. Yeah, it's not entirely straightforward, but I think it should be possible to make a PDF printout for the exercises. We'll work on that. Thanks. Okay, cool. Okay, cool. Yeah, then I think I'm going to finish this meeting. So this recording will also be put online today or tomorrow. And then I'll see you all next Wednesday. Have a great weekend. Until next time. Bye. You can print a page. I'm going to leave the meeting on for a little bit so you can finish your chat. But in principle, the meeting is finished.